First thing to do in this question is get a good sketch down. So I'm going to draw a really nice circle. Yours, might not look, it's not going to look as perfect as this, but just try and make it as round as you can. And then draw a regular octagon on the inside. Now I'm going to make it look accurate, or try to. Oops, that didn't quite work. Okay, that's pretty decent. And then I'm going to label it A, B, C, and so on. Right, center is going to be here. And then we also have APQ as an equilateral triangle where P is between C and D. P is between C and D. So I don't know where it is. Maybe I could stick it halfway, but maybe I'll just stick it over like that. I don't think it matters actually. I think that's the kind of the point of this question. But we've got A, P, and then you can see how much have we gone around? We've kind of gone over like two sides and then 2 3/4, I guess. So let's do the same again. Two sides and then like 3/4 here. Yeah, that's pretty good. Pretty good equilateral triangle. All right, it's coming together. And then finally, we're told that PD actually gives us a side of a polygon. Here we go. And then you would like carry it on around something like this. It's going to be very close to the circle, but you can see there are gaps. And we're trying to work out how many sides there are in this polygon. Now, if we know the interior angle of the polygon, then we could work out the exterior angle and then work out the number of sides. But that is not looking easy at all. Obviously we could work out the interior angle of the octagon, and then by symmetry we could say it's the same either side here, but that still doesn't really help us because we don't know what this little angle is. For example, we could work in terms of n for the number of sides, but is that really going to help? How do we get the triangle involved? Well, maybe we could do similar like over here. If we extend the polygon, it looks very messy. I did spend some time trying to do this way. I think the main issue is because the triangle is there's no like symmetry going on. Like we don't really know where the triangle is related to the octagon. In fact, it's just somewhere between P and D. That makes it difficult. I would be interested to see a solution using this approach, um, if it is possible. Instead, I'm going to talk about a very simple way of doing it. Okay, so what I'd say is I'll give you a little hint, and if you were stuck with this question, you might be able to then finish it off. But it's actually all to do with the angles coming from the center. So if I take a hexagon, for example, then in fact I can split this into 6 equilateral triangles. But the point is that I can work out this angle here, okay, because you're going to get an isosceles triangle. So it's going to be 360 divided by 6. This angle is going to be 60. And so if you know this angle, you can then work out the number of sides. It's an alternative route. Because it's at the center, this will work. So our point of attack as such in this problem is going to be this triangle here. If we can work out this angle, then it's the same idea as this triangle here. This is an isosceles triangle, so 360 has been split into n parts. We just need to do 360 divided by this angle to get the number of sides. So how do we do this? And this is where we can actually bring the triangle and the octagon into play, because I can do the approach I've got on the right, but to the triangle like this. And then this whole angle here, wait, let me just check. Yeah, this whole angle here is going to be 120 degrees. It's 360 divided by 3. But remember, Just got to think about this carefully. Okay, D is also part of the octagon, a corner of the octagon, and so is A. So I can do the same there as well. So if I connected the center, let me call it O. If I connected the center O to B, then I can work out this angle. It's going to be 360 divided by 8. But so is this angle here, and then so is this angle here. They're all going to be 360 divided by 8. So the angle, the total angle, I'm just going to now show that so it's not too messy. The total angle here is going to be 360 divided by 8 and then times by 3 because I've got 3 of these sections. Oh, okay, wow. So 360 divided by 8 is 45. 45 times 3 is 135 degrees, which is actually the interior angle of the polygon. I think that's coincidence. So we've got 135 degrees here. But what that means, therefore, is we have this angle, this purple angle. It's going to be the difference, and it's going to be 15 degrees. And now we know that angle. The number of sides is going to be 360 divided by 15, which is equal to 24. Worst, this has come up in a challenge before, I think, like this factor pair of 360. Worth knowing these, or if not, of course, you can do the short division. So I think this is a tough question, but like with a very simple solution ultimately, but seeing to do that is not easy. But that is our answer. The value of n will be 24. Well done.